Hey guys, I just want to take a couple of minutes quick and look at Theorem 8.5. Really, Theorem 8.5 is really what all of lesson 8.3b is all about, proving triangle similarity by side, angle, side. We've already looked at two ways that we can prove triangle similarity, one being angle, angle, the other being side, side, side. Now we have a third way that we're looking at. So here's the theorem, and I'm not going to slow down, so if you want to get this part, I think, is the blank, and then I didn't put the name of the theorem. So if you want to get this written down, you may have to pause it. But essentially what this theorem says is if we have a side, an angle, and a side, and the angle has to be in between the two sides that are all corresponding and congruent, then we can say that the whole triangle is similar. So the key is having a side, an angle in the middle, and then another side. If we can show that, we're good to go. We know that we have two triangles that are similar. Now, they start right off, and I love that they do this with a real-life example, because you guys say all the time, when am I ever going to use this? Well, here's a real example of when you can use side, angle, side to your advantage. You are building a lean-to shelter starting from a tree branch as shown. Tree branch right here. Can you construct the right end so it is similar to the left end using the angle measure of the lengths shown? So you start to make this ramp and you're like, hey, the ground is a little bit higher on this side than it is on this side. So when I already made this triangle on the low side. Now I'm making this triangle over here on the high side, and I need that to be similar. You know, it's not going to be the same size because the ground is different, but I need those to be similar, otherwise my ramp is going to be tippy. So you measure some things, you get out your compass and protractor, and you find out that's 53 degrees, and then you measure everything again, and you're like, hey, are these actually similar like I thought? So you've got your two triangles, and we have, well, we know that we're looking at this side and this side, and this side. So let's see if, I should use different colors here. Let's see if the orange sides are similar. If we have 6/9, that's going to simplify to be 2/3. And let's look at the red side, 15 and 10. If we have 10/15, that's also going to simplify to be 2/3, so that's a good sign. And then the angle in the middle, this 53 degrees is referring to this angle in the middle, So since angle P is congruent to angle A, then we know that we have side, angle, side, and that those two triangles are similar. So there's not really a official, T-chart proof here with our statement and our reason, statement, reason, and all that stuff. It's more like we're showing that these are proportional. I do like to point out this angle is equal to this angle. And let's say that they told us that this was right and they gave us this one, and then we had to find this one. Then maybe we would cite like our triangle sum theorem. But if they just tell us this is 53 and 53, we don't really have to do anything. So again, we're showing those two sides, we're showing the angle in the middle, and we're good to go. This was the example of the one I went through on Friday. For those that were in class, let me look at number 4. If you want to write this example down, if you weren't here on Friday, you're welcome to do that. But number 4 is the one that is on your page. We have two triangles. We're looking at this larger one and this smaller one. Now, when they give us two triangles, I always like to write them again as two separate triangles. I think it's sometimes difficult to see what's going on if they're put into the same. Now, if I'm trying to see if these are similar and if I need to show that, first I'm going to start out by saying angle XZW is congruent to angle YZXY. W. And there I would want to cite right angles congruence theorem. Next, to figure out what sides, it's your instinct to say, oh, look at this side over this side, because they share that side, but that's not what we want to do. We want to take and this is 15, we want to take the two sides that are around the right angle, the angle that we're using. We want to take the smaller one first, 9 over the smaller one over here, which is the 12. Simplify to 3/4. Then we want to take the larger one, which is 12, over the larger one over here, 16. See how this means that this really is rotated around, or you could say this one's rotated this way. So that's what's confusing about them acting like this is attached, because they're really not. One is rotated. That would give me 3/4. So I've got a side that are both corresponding, or that are both congruent, and then I've got the angle in the middle is congruent. So that means I've got two triangles, and I would list them off. XZW is congruent to triangle YZX because of the side angle side theorem. So 2 examples. I've got a couple more examples for you to do on your homework, but hopefully these will be enough so that you feel comfortable with that. If you have further questions, definitely look in the textbook or shoot me an email. The last thing that I'll point out is at the bottom of your page, I put the 3 theorems that we have looked at so far. So nothing special that you need to do with this, but I thought it was nice how the textbook laid them all out in one place.